Hello everybody and welcome to the second part of the circuits tutorial. In this part of the tutorial we will learn how to solve or come up with the truth table for two digital circuits using Boolean algebraic expressions. And Boolean algebra will not only make it easy for you to come up with the truth table for most digital circuits, but it will come in handy and it will be very beneficial for you if you study digital electronics. And it's not as hard. Knowing the notation of Boolean algebra is not as hard as it sounds. So let's get to it. So to start, what we will need to know, we will need to learn the notation first. We agreed before that if we have, let's say here we've got A and B, right? And all possible combinations and these are all possible combinations right here. So if we do A and B, right here, this is going to be 0, 0, 0, 1, correct? Because you only get one with the logical gate AND if both inputs are they are both 1. Now in linear algebra, A and B is written like this. So A and B is written like this. A and B. See this dot right here? Because if you think about it, AND is really the product of A and B. The product meaning like, you know, like in normal algebra, you do multiplication, because if you multiply 0 by 0, that's 0, 0 by 1, that's 1. If you multiply 0 and 1 and 0, it's 0. It's only 1 when they are both 1, right? So this logic makes it easy for you to understand the notation. So this will be A and B, right? Now again, if this is A and B right here, let's say again this is A and this is B, 0, 0, 0, 1, 1, 0, 1, 1. So or would be like this. It would be 0, 1, 1, 1, because you with an OR gate you get 1 if any of the input, if you have 1 in the input, right? And the way to write this in Boolean algebra is like this: A and B, right? And again, if you think about it, it's like normal addition, right? Because except for this, because you know 0 plus 0 equals 0, and here you got 1 and here you got 1. It's a sum, right? And here it is supposed to get 2, but in Boolean algebra this is 1. This is just a way for you to remember it, that AND look like this and OR looks like this. So far, maybe right here we'll write them all up. So AND is like A and B, right? Or this is OR, A or B. And we're just learning the notation, right? But it's gonna make our job very, very easy. Okay, so how's XOR? XOR is like this: A XOR B. This is the notation for XOR in Boolean algebra. What about NOR? NOR, we can say A, sorry for that. This is NOR. Why you see this bar? Because if you remember, we said that NOR is OR and then NOT, and that's what we are doing. OR and then NOT. Maybe I should have told you that this is NOT. If I have A then this is not A, or A naught. When we say A bar, so if this is 1, A bar will be 0. So that's not right here. Not A, which is A bar. Finally, NAND will be like this. Remember that we said AND. We said NAND is AND not. So you guessed it. This is going to be NAND right here, which is AND and then bar. So all we need to start using Boolean algebraic expressions is to understand or memorize these things, and it's not really hard to remember, right? Okay, so if we get to, this is sheet 3, and we are supposed to come up with the truth table for 1, 2, 3 circuits. So let's get to it. So we're going to start with the first one right here. Let's say that this is A right here, and this is B. So this is not right. So the output right here will be not A, correct? And the output over here will be not B. Now, this is a NAND gate, correct? So the output of this NAND gate is, remember that NAND equals not A, which is this column. We're going to call this not A, okay? Not B, right? Or bar, A bar and A and B bar, right? I don't want you to be scared from this, because once we draw the table, it will make a lot of sense. Now, I need you to understand that this table, how many rows will this table have? It's usually, or it's always, to the power of n, where n is the number of inputs, right? So how many rows equals 2 to the power of n, where n is the number of the inputs. So here we have 2, n is 2, right? This is equals rows, yeah? So we have 2 inputs, so we're going to need 4 rows. Okay, how many columns we will need? We will need columns, a column for each input, so 2 columns, 1, 2. And these are output columns. We're going to need an output column for each output. So this is 1 column, and 1 column. So we will need 4 rows and 1, 2, 3, 4, 5. So we need to make a table that will be 4. We're going to draw it right here because I want to show you how does that work. So we'll have a table of 4. Oh my God. Of 4 rows and 5 columns. 1, 2, 3, 4, 5, right? And here we need 4. So 1, it's not good. 1, I don't know why I did this. 2, okay. 2, too thick. 2, 3, 4. 3, 4. Okay. And we're going to start putting the labels here. So this is going to be A, and this is going to be B, A and B here. And this is A bar, and this is B bar. Now look, I'm going to make it easier for you. This column, we're going to call it 1, okay? And this column, we will call it column 2, right? So this is 1, and this is 2, right? And the third column here, that just equals A. This equals 1, column 1, and this is column 2, bar, which is NAND, column 1, NAND, column 2. If we go back here, right, look, NAND, if we say A NAND B, that would be AND, which is the product, and then not. So we are doing the same thing here, right? This is the input. The input for this column is those two columns, right? So we need to NAND those two columns together, and that's what we're doing. We're NANDing 1 and 2. So here, this column will be A bar NAND B bar, and that's how we write it. We're going to call this column number 3. Now, remember that the output is this column right here, because this is the output, right? So remember that this is the output. Yeah? Now, it becomes very easy from this point. So here we've got 0, 0, 0, 1, 1, 0, 1, 1, because these are all the possible combinations. Here, to get this column, all we need to do is to get not A, right? So it's going to be 1, because that's 0, 1, 0, 0. And this is not B, right? So not B, we need to get not of this column, right? So 1, 0, 1, 0. The output will be NAND of these two columns, column 1, NAND, column 2. Now, to remind you of NAND, right, we said this gate, NAND, if this is the input, it gives you out 0 only if the input, one of the input is 0. So once you got 0 in the input, that puts out 1, right? So it's going to be 0 here, 1, 1, 1. Voila, that's it. We have solved this circuit. And if you look at this, this is the output, because in the sheet it tells you, if we go back to the sheet, let's go back to the sheet. Here it says write the truth table for the following circuits and find their functions. So we need to find the function. If you look at this here, if you relate, we said the function is the relationship between the output, which is this column, and the input, which is those two columns. If you look at this, what gate is this? This is like OR, right? Because you're getting 1 whenever you have 1 in the input, you're having 1 in the output, right? Look. So the function of this entire gate is, of this entire circuit is like the OR function is the OR gate. Okay? This is the function. Cool? Okay. So let's try another one. Let's try this. Well, this is going to be a little bit harder, but I trust that you can do it. So again, if we have A here and B here, so the output of this gate here, right, you see B goes here, right? So right here you can have B2, right? And here you have A, correct? Okay. So right here will be A and B, and we said A and B is Boolean algebraic. We write it like this. This is A and B. Okay, what about the output right here? Well, the output right here is A XOR, because this is an XOR gate. So A XOR B. So right here is A XOR B, right? And because we said this is the symbol for XOR, remember? Very good. Okay, one step and we are done. What about here? Well, the output of this gate is what we have here XOR what we have here. So that would be A and B XOR A XOR B. Very simple. Now, if we, again, how many rows will we have here? 4 rows, because the number of rows equals 2 to the power of n, where n is the number of input. So we need 4 rows. How many columns? We need a column for each input and a column for each output. So we need 1, 2, 3, 4, 5. And just like the previous example, we're going to call this column 1, and we're going to call this column 2. And column 3 right here will equal column 1 XOR column 2. Very simple, by the way. So let's draw the table. here's the table. Okay, and okay, I'm gonna have to, okay, so here's the table. This is the label row, and we're gonna need 5 columns, we said, correct? So 1, 2, 3, 4, 5, and then we need 4 rows. So 1, 2, 3, 4. Let's put the labels. If this is A and this is B, right? So here's just A and B, and here is, this is column number 1, this is column number 2, this is column number 3, because we're only numbering the output. So 2 will be A XOR B, A XOR B, and number 3 here will be this whole thing, which is 1 XOR 2, this XOR this. So 1 XOR 2. You can write whatever labels that you want, but remember that this column here is actually the output, right? This is the output, because this column here, number 3, is this. So let's get to it. The rest is really easy. 0, 0, 0, 1, 1, 0, 1, 1. So A and B, it's super easy. All you need to do is all zeros except this. A XOR B, remember that XOR is an odd detector. So you get 1 here. The input, the 2 inputs have to be different in order to get 1. So 1 here and 1 here, right? And 0 and 0. Now, what we need to do here is to XOR these 2 columns right here, right? Because this column is this or this XOR this. So we will be looking for odds, right? So this is 0 here. These are different. So 1, these are opposite to each other. So this is 1. These are opposite to each other. This is 1. Okay, so that's it. Now, to know the function, let's relate the input, which is this, to the output. Well, again, this looks like the previous one. This looks like an OR gate. So all this entire circuit does is an OR gate again, because we're having 1 whenever we have 1 or both inputs as 1. So function again is OR. The function is OR gate. Thank you guys for watching. I hope this tutorial didn't take that much. I'm not sure if I'm going to make another part, which is the 3rd part, to solve a more complex circuit or not. Thank you guys for watching.